time. But if you're trying to separate the paint out and take that purple and extract the colors from it, that is extremely difficult. It is really, really hard work, potentially possible, maybe not. And so this is the idea of a one-way function, something that is very easy to do in one direction and either difficult or impossible to do in the other. So the one-way function that we use in Bitcoin is based on elliptic curve cryptography. And we use the SEC P256K1 curve. And in order to explain this, I would have to explain to you all these technical terms, like how we use mods and the premises of finite fields, what the point of infinity is, and what the specific generator is. But that's not necessary to understand the idea. Really, the crux of this idea right here is that we use elliptic curve cryptography as a mathematically sound one-way function. And that's what enables us to go from getting the private key and turning it into a public key quite easily, but then making sure that that's really hard to reverse. Making sure that just because people have the public key doesn't mean that they're able to reverse engineer and get your private key from it. So the elliptic curve cryptography is some like really cool advanced math, but essentially all it's doing is mixing paint and making sure that you can't extract it once it's mixed. And this idea is called public key cryptography. So based on this premise that you can go from private to public, but not public to private, there's two key functions that this enables. One is the ability to send a message. If I want to send a message to Alice, I have the ability to encrypt it using her private key. And then secondly, is that she can prove ownership, that she has the matching key, the matching private key, and thus open up the letter. So this makes sure I can send it in a way that nobody else can see it, and this makes sure that she can open it, and she's the only one who is able to actually open it. And this second one is called a digital signature. So what this enables is it enables sending money in a way that's digitally safe. And it relies on math and cryptography in order to enable that. So the crux, the one thing you should know, if you do anything in Bitcoin, if you buy it at all, you should know that your private keys are your Bitcoin. If you take nothing else away, just know that not your keys, not your coins is a really great meme in this space, because what it means to own Bitcoin is owning private keys. And if you purchase Bitcoin through a platform like an exchange or something like that, then they might be storing your private keys for you. And that might be okay. That might be what the stage of involvement that you're interested in. But you should know that they have your Bitcoin and you're trusting them. So make sure it's an entity that seems legit. Similarly, if you decide that you want to store your own Bitcoin, you know, like instead of having your money in a bank of some sort, have it in your own house or something like that, you should know that if you lose your private keys, then you lose your Bitcoin. They really are kind of one and the same, because the crux of what Bitcoin is being able to transfer funds based on these private keys. So that was the first concept. And now part two is proof of work, which is how the system kind of comes together. Part one was about how you send money and make sure that only the intended recipient can use it. Part two is how the system validates that or enforces that, and that's via proof of work. So in order to understand proof of work, we're going to start with hash functions and another kind of silly metaphor. This slide tells you pretty much what a hash function is, where you can take objects of different sizes, shapes, data, and turn it into something that looks kind of homogeneous. So in practice, it looks more like this, where I can take the word hello, which is just an example string, and if I run it through the SHA-256 hash function, then I get this string of numbers and letters that you see on the right side. And there's a few really clever and like just so cool properties about this hash function or hash functions in general. One is that it's deterministic. Like hello will always match that string. You can try to run it. We could try to run it a million times. It will always match that string. Two is it's a fixed size. So on the left, whether I'm putting in the word hello or whether I'm putting in like all of Shakespeare's texts, on the right, I will get the same size of string. So that's really helpful in terms of predictability. And three, it's unique. So this has a little bit of a caveat, but for the most part, it is absolutely unique. And if I change hello to have an exclamation mark, or if I change the O to be a 0, or whatever I do, I will get a totally different looking string on the right side that will be the same size. It will always be that string, and it will be unique. And then it goes back to that one-way function of it's really, really hard to reverse. If I gave you this string on the right side and just said, hey, what do you think this is? Or like, what string does it match to? What you would have to do is go through a dictionary or some sort of brute force thing and just go, what is A map to? B, C, D, and like keep brute forcing it in order to potentially hit hello and then get the same string, and then you can match it up and be like, okay, cool, that's the same. But there's no way to get this 2CF24 blah, 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 and go, oh, I know what that is, it's hello. So one example of where this is very commonly used in Bitcoin is for the transaction hashes. So if you go to a Bitcoin block explorer, well, I went to a Bitcoin block explorer and I just did a screen grab that pulled one transaction. And this is essentially using a hash, and it encapsulates the idea that Alice sent Bob X amount of, Bitcoin, and this much of a fee was spent. There's a bit more nuance to it, but this transaction hash is able to be a predictable length string that is encapsulating all of this information about the transaction. And what that enables is if I'm a node on the network, I can make my transaction, put it up in a hash, and then send it out to the network. And because of what we've learned about one-way functions and public key cryptography, they are able to propagate this. It's small enough they can send it around, but they can't see the contents, or they can't open it up and spend the transaction themselves. So then proof of work builds on this idea. And essentially here, there is a type of participant in the system called miners. And they put a bunch of those transactions into a block, and then they solve a puzzle. You might have heard this, they solve a cryptographic puzzle. But essentially what that puzzle is they run that block through a hash function, the SHA-256 hash, which we've already seen. And then they get some random looking strings, and they're considered a winner if there's a certain number of leading zeros. So they keep like taking that block, hashing it, maybe changing a little bit of something, hashing it again, and like just repeating that, brute forcing until they see that there's a bunch of leading zeros and they go, yes, I won. Let me get this out to the network. And you can build on what previous blocks that were sent out. So you put them together, like that's part of when you build a block, you refer to the previous one, and that's what creates the blockchain. And so if you're trying to mine a block on the current chain, you would just have one reference to the previous one and then hash it till you get leading zeros. And then you have a valid block and you can give it out to the network. And it's really elegant because of these properties of like one-way functions is that, and hash functions is that I can receive this block and I can see that you put a bunch of work into it because you have all these leading zeros. And as long as it refers to the previous chain that I'm also aware of, then I can know that this is valid, that this is legitimate. And one more rule that makes this really work is that if there are competing blocks, the way that that is resolved, because there might be multiple blocks that pick up transactions, refer to the previous chain, get leading zeros, but are slightly different. So then they would have very different hashes. But the way that this gets resolved is by the heaviest chain. So the one which has the most work on it is the one that the network will accept. And I, as an individual, validating and participating in the Bitcoin ecosystem will prioritize. And so this is really the crux of what Bitcoin is, what the innovation is that it has proposed to the world and why it can be money. So as long as this assumption holds that you cannot predict a hash, then it is true that you cannot fake proof of work. So that is a fundamental premise for the security of the Bitcoin system. And then when a miner mines a block, they send it out to the network. And then each node on the network can look at that block, look at the leading zeros, and see that it is on the heaviest chain, that there's the most work done on this chain, and then accept the transactions that were in that block and update their ledgers of, okay, this is Alice now has this much money, Bob now has that much. So that's it. That's the fundamentals of how Bitcoin works. Kind of these two concepts put together in a very elegant way has made it so that we can have this global digital inclusive money. Obviously, it's a bit more complex, and there are a lot of edge cases, et cetera, to think of. If not, I wouldn't have a job. But this is what the system hinges on, and this was the crucial concept that Satoshi Nakamoto presented in his white paper, and that has caught all of our attention. So I want to just do a quick mention of, if you're interested, kind of some different ways of engaging more. One way is to buy Bitcoin, invest financially in the system, or you use it. But if you're going to do this, if you have done this, the one thing I really, really want to hammer is just know who you're trusting with your private keys. Whether it's a company, whether it's your friend, whether it's yourself, just recognize that that is who holds your Bitcoin, and the private key is your Bitcoin. Another cool way is to earn Bitcoin. There's a lot of different creative ways popping up. You can always do this direct. There's a project called BTC Pay Server if you're like a business or have some online services that you can enable. But there's a lot of creative ways if you just like Google, we're interested. If you're interested in learning more, I put 3 books that I really like, all called Mastering, Programming, or Grokking Bitcoin. If you're interested in the technicals, I would recommend that. Those are kind of a scale of different depth of technical, but of course there's lots of ways to learn. I would also say Andreas Antonopoulos is a very eloquent speaker about Bitcoin and related technologies. And my favorite is building. You can build a community, write code, teach other people, write blog posts, make stuff. And I really, really, really love working on Bitcoin. I find it very engaging intellectually, very impactful. So if anybody was ever interested in exploring what it would be like to onboard to Bitcoin Core, or different possibilities of projects that you could contribute code to, please reach out to me. I'd be very, very happy to have that conversation. Cool. So